All right. And I knew there was another column I was missing. We want an A showing up here. A d times D squared. All right. So our area times the distance is actually the height here. So get out of there. What we're looking for is these are the D's, each section here. So that will be the D, okay? Because we're looking for the height of the change from where the centroid is going to be, okay? And we can do this down in the equation, or we can do it up here. Matters not, but it's going to be a little easier because you got your A over here and you got your D. So it's a matter of taking A, the 10 by 1 is 10, and the height of that whole thing is 1 also. Okay. Do that right? Did I do that right? I did do that right. No, I'm not doing that right. Okay, let me back up here. Sorry, I'll get my head back in this game and we'll go from where we're supposed to be. The D that I'm looking for is from the, zoom in on this for a minute. Let's try a different color here. Which haven't we used? Let's use blue. We haven't used blue. So I'm trying to figure out where it is from where our baseline is here, okay? So our D for this one, C, will be D of C will be 1 inch, and D of B will be 1 and 4 is 5 inches, okay? And then D of A will be 1.8 yeah, because it's, okay? And what that is it locates the centroid of each object with its area relationship to where the baseline is. Okay, so the bottom is 0, we called it, but we could call it any place else. Yes, DC is 0.5. Thank you. Yes. Okay. Everybody good so far? It's complicated and it's confusing, so don't feel bad if you want to ask a question. Yes, sir.
Is DA 3.5 or 3.5?
Yeah, it better be 3.5. Where did I get 5 from? 1 and 4 is 5. No. The bottom, so we go up 1. And the center of section D is at 4. No, it's 5. Right?
Okay. No, I can't read it.
Oh, you're asking if it's 3.5.
Yeah.
No, it's 5. Sorry. So, let's do this again. So I'm coming off this line here, finding the centroid of each object in the shape. Okay? So up 0.5 to that center. Everybody good? this center here is this 8-inch, but half of that will be 4. Plus I got this 1 inch in the bottom here. So far so good? And then literally 1/8 is 9. Did I do that wrong? 9.5 instead of 8.5. 1/8 and then half of that 1 would be 9.5, right? All right. Now I think we're good. Yes? Okay. So literally over here to this last column, AD squared is now going to be A, which is the top one, was, I'm going to do it mathematically here, so the 10 inches squared, let's write that so you can see it. So 10 inches squared is the area, and I'm multiplying it times 9.5 inches, and I'm squaring that, okay? So it's not 9.5 square inches, it's 9.5 inches squared. Good, Fidel? Okay. All right, what's that number come out to? The one I got planned for today is a lot simpler than this. Hopefully. I just picked this one out of my hair, but should have known better. Complicated to get. Now?
9,025.
9,025 inches to the fourth.
902.5. Yeah.
902.5. I'd like 902.5 better. Because 10 times, well, 9 would be 81, right? And that'd be 8,000, no, it'd be 810. And then you do the 0.5. Did you by chance just miss the 9.5? Put it in as 95?
I think you put 10 inches squared times 9.5.
Yeah,
Oh.
I did that.
So this, when you do this bit, folks, it's important that you keep the areas are already squared, and the D is something you're going to square, because we want it in inches to the fourth. All right, so let's try the next one here. So we got 8 inches. Inches squared, and this came out to be 5 was the D. And we square that, so 25 times 8.
200.
Okay, and then our area for the bottom was 6. And we were at 0.5 inches squared.
1.5.
1.5? Okay. All right. Now, I'm doing this with all the places in the table, and I'm going to introduce you to the equation so you don't have to do these last two out this way. So it's your choice. Okay, you can always tableize it, or you can just come down the list and do the equations, okay? But what we're looking for here is the I. Oh, I'm sorry. Before we do that, let's find the centroid. Find the centroid. This is the easier one of the two. Okay? And this is going to be y bar O is the label for it. Y bar O is going to be equal to the summation of the AY bars divided by the summation of the A's. Yep. Okay? Good. All right. So, say this so that maybe you can help put some perspective in it. I'm looking for the centroid, right, which has got to be in inches, a known fixed location. What have I actually created in this table, and then what I'm using in this equation? I made it a ratio of the areas, right? And they will actually solve all this stuff for me to get the y bar knot, or where the actual centroid is. Make sense? Okay. So there's some logic to this. So if you get lost on this, which you probably will, I want you to remember how to do that. So basically we take the sum of this column and that column, and we can go find where the y bar is. So 10, 8, and 6 is?
18 plus
19.
24.
24. Okay. And the summation of 95, 40, and 30 is? 138. Everybody agree? Hearing no dissenters, we're moving on. 138 inches cubed divided by 24 inches squared. I'm going to clean that up, make it look like an 8. What do we got for a number? .75 inches. Okay? Everybody good? Mathematically? Okay. Now let me show you where that thing belongs. And I really do think I want a different color here. So let's try, yellow doesn't really work well. Purple does. So we are 1 inch up here. So there's 1, 4 is 5. But our centroid we just decided was 5.75. So we are literally right there. YO bar 5.75 inches. Make sense? Okay, I want you to ask, I'm going to ask you this to make sense. I want you to understand, is it in the right place? What has more mass? The top of this thing or the bottom of this thing?
Top.
The top. So the centroid should shift towards the greater mass, right? Because literally what's this? Oh, let's go look at that stupid model too. What's the centroid? It's the place. Ooh, we got to yes! Sweet. Greatest things in physics. About the only tool I ever remember in physics. Give or take, is that perfectly balanced? Is that where the centroid is? Yes, because there's all this extra weight out here. Now, you take Yes, I know I can use. The other greatest joy in physics is putting holes in rules. Alright, so we got this little extra weight out here now, right? So where's the centroid going to be? It was at 50 millimeters earlier. 500 millimeters, 50 centimeters. It's now at 47.5 centimeters. The weight's this way a little more. This has to equal this. Centroid is really about where the balance in life is, okay, or in the structural part of the design. And literally, all it takes is that little thing just rolling slightly out of position, and we can't get it down. Okay? Make sense? Cool. Bet you didn't know that from physics. If you did, forgot to leave it. All right. So we're in a good position there. We got our Y bar. I do with a pencil.
Wait, so if that's those only two variables we need to find out the centroid, why do we need?
Oh, we're not done yet. Well, we're far from done. So we need to know the summation of the moment of inertia of this thing. Okay? So think about this as a figure skater. Okay? So you got one long arm, one short arm. Okay? We know where her centroid is as she spins, right? It's someplace on the right side of her body. What's the moment of inertia going to be? And that's what we're looking for next. Okay? Now, so it is two sets of different equations here. So let's do this. Actually, I'll do it in purple. Do that. Make it bigger. So we can sum up this, and we can sum up that. Okay? So we can have a summation. So I total is equal to the summation of I, the individual, plus the summation of A D squared. Okay? And the reality is, okay, that's great. You can tally that up, right? The other equation that makes everybody's life just a little bit easier is just doing this. Let's do that so you can actually read it. I1 is equal to the base times height cubed over 12, 4, 1, plus the A1 D1 squared. Okay? And then I2 equals B2 H2 cubed over 12 plus A2 D2 squared. Okay? And then I3 equals B3 H3 cubed over 12 plus A3 D3 squared. And then IT is equal to I1 plus I2 plus I3. Okay? You can choose any way you want to do it. Okay? I don't have the magic lock on which one's the right answer. Okay? The only thing that I know from practice is it makes a neater table if you do all the calculations that I did up in the table, down lower in complication. Okay? And then just fill the table in. That makes sense? Let me restate that. So all the stuff that I did up in here with this stuff and all of this stuff, you're going to have to show it to me. So it makes sense to do it down at the bottom with the equation. If you want, you can just go back up and fill a table. But truthfully, really what you need is the first 3 columns in order to do this problem. Okay? And after that, the rest is just know the equation. Okay? All right. I'm going to do the next problem that way. Let's solve this one. So, summation of the stuff here in 0.83, 4.267, and 0.5 is. Go ahead, Tyler. Inches to the 4th. And the second set of data we need is 902.5, 201.5 inches to the 4th.
1104.
1104. Okay. So literally if I come down here to the purple, it should be 44 inches to the 4th plus 1104 inches to the 4th, and we should get 1148, right? So that's my I. So we know the moment of inertia, and we now know where the centroid of this thing's revolving about. Pretty good? Okay. There are some great ways to do this with some calculus, but you don't need to. Okay. Honestly, most engineers forgot how to do the calculus anyways, and you just do this by hand. All right. Not that you shouldn't forget how to do calculus, but trust me, 10 years out in the field, you're going to go, calculus? I thought, that's no joke, I was going to put sprinkler heads around the lawn one time for weird shape. It's like, ooh, I can do this. It's just the integration of the area of the fence line. Yeah, I had to come up with the equation for the fence line first. And I was like, screw that. I'm going to go find the areas of the geometric shapes I can put in the yard, and I'm measuring them up and just going that way. All right, everybody good on that? So we got our answer. You can do this method down here with this and do the summation of each of them that way. Perfectly fine, I don't care, whatever works for you. But literally in the table, just keep your answers in the table. Okay, make your life a little cleaner and neater. Okay. All right, let's do another one. And actually this one I think you guys can try to do together, or do, yeah, you can do it together. It's not like we're cheating anybody here. All right, this is L17 today. Wow, 17 days into the class. All right, so here's this problem. We have one, two, three, up and over. Okay, that's not very geometric. Hold on, you're gonna appreciate this if I do it right. We are 2, 3, 3, 3, 2, and we're going up 6. Cool. All right. So we got our line here is Y. We're going to call X here. And we are literally 3 by 3 by 3. Did I give you inches, units, feet, inches? All right, and we are 2 inches here. And what else we got? Cool, I think that's all we need. Okay, so table. We got part 1, which was, come on. Yeah, this one up here is going to be part 1. This one will be part 2. So I'm going to draw a little dashed line across there to separate them. And we're literally going 1, 2, summation, and we're going to look for our YO, or not our YO, our Y. And we're going to look for our A, and then we're going to look for AY, don't do the O, there. Okay? And we're going to fill in the table. All right. So, what's the area of 1? Oh, we need another dimension here. Sorry. That would be helpful, wouldn't it? So 6 inches there, 2 inches high on the bottom, 3 inches, and we're good. All right, Y bar for 1. First thing you gotta ask yourself is what? Where are we gonna rotate about? What's our 0 gonna be? Okay. Yes? I gave it to you, probably. Put X on the face. But you can pick X. You could pick X if you wanted to. You could put an X right there and not use this X. All right? And that's perfectly fine too. You get to choose where you're going to rotate about. Okay? Problem is this bottom starts with a bunch of negative numbers then. Okay? So it's always easier to choose something where you know you got some solid idea where you are in space, right? Okay. So this beam's going to sit on this thing. So we got our 0. So Y bar for this thing will be where? How far up from X is the centroid of 1? Okay, so there's where Y1 is going to be. And I'll even give you the benefit of the doubt. There's Y2. Okay. So what's the dimension up to Y1? Got 2 inches to the base one. And I got to go halfway into the next one, right?
2.5.
Be 5 inches. 2 plus 3. Everybody see that? Loge? Cool. That's what I'm looking for. So I'm going to call this 0. Okay? I want to find out where I just put Y1 in the purple here. So I got to go up 2, and then up 3 to get to that because I got to find half of that. Okay? Cool. All right. So we are a 5 over here. Okay? And probably should put the units up in here so we don't have to deal with all that. This will be inches squared, and this will be inches cubed. Okay? All right, what's the area of 1? 18. 3 times 6 and 18. Everybody good? All right, and as long as we're there, what's 18 times 5?
90.
Cool. All right, now back to 2. Where is y2 sitting for object portion of number 2? Where? 1 inch. Everybody see that? Hello? From here up to there, is half of 2, yep. Okay, so, I'm telling you, I don't care how much stuff you write down in your paper, as long as it's useful to you, okay? And the only other thing I care about is it neatly organized. Yes? Thank you, Mark. Neatly organized because we're very organized people, okay? So if you write stuff down there, just make sure you're telling me what it is. You got to write y is equal to h over 2. Do it. I don't care. You're not hurting my feelings any. Truthfully, did I ever tell you about the NASA problem with stupidity? No? I haven't told you about Mars and the polar lander? No. Okay. Writing stuff down will save you billions of dollars. Okay, sometimes taxpayers' money. So, about 10, 15 years ago, they decided they needed a lander to go to the South Pole of Mars so they could see if there's ice down there, okay? Satellite image around the planet was kind of detecting there was something reflective there, and they thought it might be ice. If we were to go to explore Mars, we need a source of water, okay? And water, although probably very plentiful in the universe, is not easy to find in the voids of space. Okay? So if we could find ice, then we know where we could start exploring and put humans there, because if you don't get any water, 3 days you're dead. Live without food for, 40-something days or something like that. But, you need water. No, it's not right. Wouldn't be very happy if you weren't eating either. But so they decided to do this. Well, of course, being a great government contractor, we decided that we were going to send it out to 2 different companies to actually make the parts of these. Okay? They did not write down how they wanted the units specified. So one company did it in metric, another company did it in English units. And you know where the Mars lander settled to? 90 meters below the surface of Mars. Because somebody failed to recognize 2 different unit systems, and the computer couldn't do anything to stop it. By the time it was burning the retro rockets, it was already 30 meters into the planet, they said. 90 meters is where it stopped. Hell of a lot of money just went up in smoke. And on top of that, it's not our planet. We're blowing it up. So, anyways, so be careful that you're writing your units down and doing things. Why'd I go off on that tangent? Keeping things neat and writing them down. All right. Somebody would have saw it if they wrote it down. All right, what's the area for 2? 18. 9 by 2, right? Okay. 18 times 1? God, it ought to be 18. All right. Summation of y bar. You can do this one, but did we really use that in the last problem? No. Okay. So I usually just put a dash line in just to remind myself, don't waste my time. Yes, Alosh.
What's the equation for AY?
AY? 1 times 18 is 18. Okay. 18 summed up on both things should be 36, right? And then 18 and 90 should be 108. No, yeah, 108. What am I thinking? All right, so far so good? Okay. You guys got 7 minutes. Tell me what y bar is, and tell me what the moment of inertia is. And actually, if you want, put your name on it, hand it in as a quiz. Oh, who said that? Just put, all you gotta do is put the answers down, you don't have to do it all in order. Okay, I need more grade for you guys. I think I got your other stuff still sitting up on the desk. Where are you going, Justin? So all you gotta do is find y bar. You gotta find the summation of the 2 moment of inertias. So y bar is going to be this divided by this summation. So 108 divided by 36 is going to be y bar for part. And then you want to do the moment conversion. So 108 so that's your y bar, 2 inches. Subtract that y out. Now your next one is your I, which is going to be rectangle. I is equal to base times h cubed divided by 12 plus the a times the b, which is using this baseline here. Okay, you're going to do that twice, and then sum those 2 i's together, and that's your one inertia. Well, no, so separate them into 2 parts. So think of it this way, okay? And y1 will be from here, this is where our x is. We're going up to the central here, so there it is here, which is what I gave you here, 5 inches up to there. Okay? And your base for this one is 3, and your height is 6. So you get 1 equal to base h cubed over 12 plus a d squared. Okay? It's going to be 3 inches. 6 inches divided by 12 plus the area, which is there, 15. Okay. And then the only one that's not in the table is B. We're going to go from here to there. And that D is 3 there, 2 there, 5. all that up. You do the same thing for 2 on here, the base one. Do the same thing with some I1 and I2 there. I told.
Yes, hold.
Okay, what you missed here is the area. You're right there. Got it? No, Tyler, you're off by about 40.
Is that right? Like 108 divided by 36.
Yep. 3 inches.
So
So you're coming up here, you'd be right there. 1 inch above that, 2 inches below that.
so might be the 44. So might be an answer 44. Where this came from? Like add
44 inches squared. So this was on the table just day before.
so add these two numbers right there. From there, right?
Yeah.
Just your time. Can you come talk to me after you're done?
Yeah.
No.
Yep. I'm not sure you get that. Let's go back and look at the notes here. Don't, when you get done class, stick around. Oh, that's the one. Where's the one in a minute? Come on. Let's do it. Yeah, when you get those two together, add up that, there's Centroid, there's I, a T. Also here, it should be, which is 4 here, which is squared, which is squared is 5. 2 right there, it's 40.5 times 18. Yeah. That's right. Wow, either I did something wrong with I, or everybody else is doing something wrong with I. Oh, yeah, you guys are doing something wrong with I because I think I led you down that. It's a horrible mistake. Not that I think I did it to you, but remember, once we find the centroid here, we are looking for D is this one, and D is this one. So that D is not the Y bar that we're looking at. It's the distance from where the centroid of the shape is to the real centroid of the whole object. I'll do this one out for you, and we'll try it again, okay? Let me put the answer up, and then we can go from there. So everybody got
B.
this part right, which was 108 inches cubed over 36 inches squared. Turned out to be 3 inches. Okay? So that's where this is. Equals YO. Okay? From there up to there, D1 is 2. From there down, D2 is 2. Okay? So when I go do this, I is equal to base times height cubed over 12 plus A D1. And I'm going to square D. We're going to get 126 inches to the fourth, and I2 will be base 2H2 cubed over 12 plus A2D2 squared, and that answer will come out to be 78. Okay? Inches to the fourth. And that means I total is equal to I1 plus I2. Okay? And that should be 204 inches to the fourth. And that's our answer. So we need 3 inches and we need that. Write that down. I'll let you go. We'll spend some more time on this. Don't worry about the quiz. But it did tell me what I needed. You guys are lost, which is acceptable, okay? Because if this is not the easiest part of this whole class, this part is the tricky part that will get you and fight you on a regular basis. So we'll do some more of these on Friday. Yeah, Friday I will give you some homework for these, but we'll spend 2 hours just cranking these out, okay? And maybe by the end of that you'll get them done. And maybe I'll give you a quiz at the end of that. So you can go into your book and do some reading on this though. Cool. Everybody have a great day.